So we have talked about it takes whatever the number of sides are of your figure, you're going to take off 2 sides and multiply times 180 to get your total number of degrees of angles inside any size polygon. That's as long as it's a convex polygon and doesn't cave in on the sides. But these three, I want to mention our definitions as well. Equilateral, we hopefully know what that is as a triangle, but any polygon can be equilateral. It just means all sides are equal. So this is a hexagonal equilateral figure, okay? Equiangular, all equal angles. So this is a hexagonal, I think that's the right word. A hexagon with 6 equal sides. Those two combined together are called a regular figure. Okay, so an equilateral triangle is a regular figure because all angles are equal, all sides are equal. What is the 4-sided regular figure?
Square.
Square. All angles equal, all sides are equal. So make sure you highlight the word regular, and then I box this in because that will be important whenever it comes to finding individual angles if we have all of the angles equal. All right. Next, we discovered in what we did just a second ago, the interior angle sum theorem. Make sure you highlight the word sum for sure. This is the total number of all angles inside any polygon. This is a formula to use. N being your number of sides, as we discovered, you would take 2 off of that and multiply times 180 because this number gives you the number of triangles times 180 to get your total number of degrees inside. Okay, now let's say in that figure, hexagon, we just did that a while ago. Let's do that again. 6 sides minus 2, 4 sides times 180. Remember what was that?
720.
720 degrees. What if I wanted to find each of those individual angles in a regular figure? 720 would be split into how many different angles? 6 angles. This is the formula for a regular polygon. Make sure regular is highlighted, where you're going to take that total and divide it by, again, the number of angles, which is the same number as the number of sides, and then you would have only 1 angle. So 720, let's just do that real quick. 720 divided by 6. 112 degrees at each of these angles. Okay. I also want to point out that, let me grab a pencil. This next theorem that we're about to talk about is called exterior angle theorem, or sum of exterior angles. I want to look at, okay, this is just you guys watching for a minute. I want to look at a triangle, any shaped triangle. Let's say this is 80 degrees, 40 degrees, that's 120, so this is 60 degrees. Okay, if I were to draw exterior angles around this triangle, I'm going to have to go the same direction like a little pinwheel. So here's my exterior, here's my exterior, here's my exterior. How many degrees would be at this exterior angle? If this is 80?
120.
Not quite that big. 100, because together they're supplementary, right? How many degrees would be at this angle? If that's 40, this is going to add to 180.
120. 5. 60.
180 minus 40.
Which is 140.
Yes. Okay, testing your brains this morning. 180 minus 60 at this one is, there's your 120. Okay, what's the sum of all 3 of those exterior angles? Add them up for me real quick. 120 plus 140. 260 plus 100.
360.
Okay.
360.
360, like you're going around the figure, 360 degrees is that exterior. Okay, I want to use the same idea with a rectangle. 4-sided figure that has all right angles. What is the exterior angle here? I need everybody watching and listening. Exterior.
90.
90. What is the exterior here?
90.
And here.
90.
And here.
90.
So going around, total all those 90s, and you have a total of
720.
360.
not that big. 360. If I did the pentagon, the same thing would happen. Exterior angles, as you notice right here in this theorem, and I wrote the word exterior next to it for you. Exterior angle sum will always, no matter how many angles there are, will always equal 360. Okay, so I want to show you a nice little side note. If I had an octagon, 8-sided figure, let's say this is a regular octagon, it's supposed to be, where all angles and all sides are equal, and I wanted to find an interior angle. I actually have two options. Okay, so listen carefully because you can use either option. I'll tell you the one I prefer, but I'll show you both. I could find, using my formula up here, I can find all total of 8 degrees, n minus 2 times 180, and divide by 8, and I could find that angle. Okay, let's do it that way. Y'all help me. How many sides?
8.
And how many triangles? So I take off 2. 6 triangles. Each of them 180 degrees. So I'm doing 8 minus 2 times 180. That's going to give me what?
9.
I think that's right. No, not the 9. I did that multiplication, but y'all might want to check. 0, 48, carry the 4. Yes, that's right. Okay, 1,080. That's my total, but I want to know one angle. So what am I doing with this total amount if this is a regular polygon?
Dividing it by a number.
A number that is the number of angles in that figure. How many angles in an octagon?
8.
So divide by 8 for me.
135.
Oh, is it a 3? Darn. Okay, 135 degrees at each angle. So you can go through that process to find your angle because we followed the formulas, or this is my preferred method. Okay, how many degrees does it say all the exterior angles are of this polygon?
A lot. 1080.
Always, no, degrees exterior.
Oh,
360.
360. If I can always remember that exterior degree angle, think about this. 360 is cut into how many exterior angles in an octagon?
8.
8 of them. If I just split that into 8 pieces, that's 45 degrees at each exterior angle. How could I take that 45 and find the interior angle?
Subtract it from 180.
Yes, because the interior and the exterior are supplementary. So my preferred method is not really to use this formula to find an interior angle. It's to use the exterior angle and then subtract from 180 to find 45 to find the interior angle. Okay. Either way, you can work with that and figure out what your angles are in your figures. Okay, moving on. Let's write some examples down. So this is kind of a list of examples here. We're going to follow each one. Let me just have you write for example 1. Sum of interior, underline interior of 20-sided figure. Okay. Sum of interior of 20-sided figure. Kyle, if you write it on this paper, you can take that paper out and put it into your journal.
Wait, what?
You write these examples
why
down
doesn't
on
he just
this
glue this?
paper, or you can write them out on the side here. Okay. All right, so writing down example 1, sum of interior angles, 20-sided figure.
36. Oh wait, interior.
Interior.
Okay, so there's
how many-
360 exterior.
How many sides?
20.
I want to use my formula because there are 20 sides, take off 2, and then I multiply times 180. So what's getting multiplied times 180?
18.
Okay, so 18 times 180, and that will give me my sum of all 20.
32.
3,240 degrees. That's sum. And on the first part of your homework, you are finding just sum of all interior angles. Does everybody understand that formula? That concept. Okay, example 2 is take that a step further. Find measure of each interior angle.
Divided by 20. Right?
Yes, but write down what you're doing. Example 2, find measure of each interior angle. That's if it's regular, because all the angles would be equal. So that 3,240 we just found, A lot of people will want to divide by 18, but that's not dividing by the number of triangles. You want to divide by the number of angles.
162.
You're dividing by 20, the number of sides. 162 degrees.
Yes.
So if you want to put that into formula form, that would be n minus 2 times 180, but divided by the number of sides. So I'd already done this. That was the 3240, and then divide by the number of sides, 20. Okay, that's my interior angle. Now I want to find my example 3 exterior angle of that figure. Okay, 20-sided figure. Find exterior angle. Okay, what's my total of my exterior? 360 total. How many exterior angles do I have in a 20-sided figure? 20. So I want to know one of them.
So
360
divide by 20.
divided by. What is my
18.
exterior angle? 18 degrees. Okay, those were my 3 answers. We had we had one angle, we have exterior angle. Now, next to this little combination of information, I know we can't, well, y'all probably could, but I can't draw a 20-sided figure. So I want you to draw like 3 or 4 of the sides of a figure. And then inside, we're going to put 162 degrees. Outside, we're going to put that 18 degrees. So it kind of shows, and this is 20 sides. So it kind of shows the little setup. What we just found. Interior, 162 degrees. Exterior, 18 degrees. All of them together, all 20 angles, 3,240. Okay, once again, I'm just going to remind you, if I had to find this information without having to go through every one of those steps, I would just say, okay, it's however many sides, 360 is my exterior angle. I'm going to take 360 and divide it by however many angles, and I've got my outside angle, and then these two must be supplementary, so then you can find your interior angle also. Okay, question there? We're going to take that a step farther. Example 4.
Turn your phone off.
It's broken.
That's what they all say.
Okay, example 4, please write down. If the interior angle of a regular polygon is 120 degrees, how many sides does it have? Interior angle of regular polygon is 120 degrees. I want to figure out how many sides it has.
30. Oh.
Okay. Oh, it might have 30. I don't know. Okay, once you get that copied, I'm going to change over to my paper so I can work it on paper because that's not really enough room right there. I don't know how many sides. I don't know what size figure. I just know I have an obtuse angle. So this is what I want to start with. Obtuse angle of some polygon. Oops.
Ow.
Interior angle is 120 degrees. I have 2 options. I can use the formula n minus 2 times 180 divided by n and have it equal 120 and solve for n. That's using the interior. Or
The interior.
let me think about the exterior angle. Could I find my exterior angle?
Yeah.
Yes. Because the equals 60.
Okay, first of all, can I find one of my exterior angles?
60.
Yes.
Yes, because it's supplementary. Okay, so this is 60. And then my exterior angles always equal what?
The same thing.
The same amount, which is always
360 total.
360 total. Okay, so you've got options. You can set this equation up and solve for n, the number of sides. Or if I have 360 degrees total, but I have one angle at 60 degrees, how can I figure out how many of these it takes? Yeah. So rather than doing all of this algebra, my choice is, okay, 120 is inside, so 60 is outside. So if I divide by 60, that will tell me how many angles there are. What's 360 divided by 66? This is a 6-angle figure, which means this is a 6-sided figure. And wasn't that much easier to use the exterior angle than using that formula and doing all the algebra? Okay, so that's my suggestion. If you want to do the algebra, you would multiply and move that n over here, and then you would solve by distributing and so on. But
It's
so much easier to think the exterior way. Okay. Okay, last example. In your journal, please draw this 4-sided figure. Oh, is this a regular figure?
No.
Equal sides, equal angles? No. This is just a quadrilateral, 4-sided figure. Okay? Please draw. These are all labeling the angles, so these are degrees.
I know what to do.
Plus 10.
We're going to find the value of x and then figure out what each angle is in this
But I
figure.
know what it is.
7x plus 10.
Okay, so 7x plus 10, but what is it going to equal?
Equals 180.
That does it.
No.
360.
So the
Good.
same concept that we use
It's two
for our
triangles.
Yeah.
Yeah.
okay,
I
same
see.
concept we use for our triangles that equal 180. We're going to use for this figure, but when we put these together, that's 7x plus 10, 2x plus 3x plus 1x plus 1x, 15 plus 15, 30 minus 20, 10. It does not equal the same amount as a triangle. It equals 2 triangles, which is 4 minus 2 times 180 degrees. So 2 triangles times 180 is 360 degrees. Okay, so what did I just do? Went through my formula to find the total number of angles in a 4-sided figure. Whether I knew it or not, I could find it by this formula. And now all those angles will equal my 360. Now I solve for my x. Y'all solve real quick. Not using 180, but using 360. So you gotta retrain your brain a little bit. We're not triangles now.
50.
Subtract 10, divide by 7. I believe, yes, you do get x is 50. Okay, so y'all help me find angles. What's this one?
50. Yeah, 50.
50. And this one, Kyle?
65.
This one, Skylar?
115.
115. And Holly, are you punching this one in? Okay. 130. Okay. For a 4-sided figure, we can't tell like what we just finished with our triangles, like which side's larger, smaller, whatever from that. Actually, I guess we could. No, because this is opening up to a totally different thing. So we can't do a comparison as far as large and small, but we can find our angles. Okay, so that's the extent of today's notes.
Awesome.
Thank you for listening. I know that was a lot of notes.